Okay, we're going to review the polynomial standard. Now, here's my highest power, okay? It's a 3, so if it's higher than 2, there's no pattern, it just goes all over the place. So if it goes all over, the only thing I can do is input 3 through -3. Okay, you should know what 0 is, because that would be, that'd be 0, and then we'd have a -3. Okay, so now I'll show you how to insert, and then I'll tell you the rest. -2 and then 3 to the power of 3 plus 7 times 3 to the power of 2 minus 3. Gives me 6. Now I'd repeat the same thing, except I put 2 in. By the way, power of 3, you hit this button, and then 3. Okay, so I get 9, 2, and then 6, 41. I'll just tell you, that's kind of an outlier, so we're not going to graph that. So 3, 6, 1, 2, 3, 1, 2, 3, 4, 5. Or I'm going to go by 2s actually, because I need to, by 5s, I need to hit 41. 5, 6, 2, 9, 5, okay. 1, 2, remember we're going by 5, so 2 would be somewhere in there. 0, -3, so right somewhere in there. -1, 6, so left 1, then 5 right there. -2, 41. 5, 10, 15, 20, 25, 30, 35, 40, 41. Now we connect the points in the order they were made. Now, is your leading coefficient, is this positive or negative? It's negative, so this arrow here needs to curve down. If it's negative, if it's positive, it curves up. Now the other arrow, because I need the arrows right. The highest power here is odd, okay? So if it's odd, they go in opposite directions. So that's going down, that's going up. Okay? We're not doing the next page. That's not even on the assessment. Now we're simplifying exponents. So there's no adding and subtracting. It's all multiplication. So I make my boxes. So my bases are 6 and x. So 1 times 4 is 4, 3 times 4 is 12. There's no negative power, so this box is useless. Okay, I need to find what 6 to the 4th power is. 1,296 times x to the 12th. I don't need anything in the denominator. Now, if we have an empty numerator, that's another story, okay? Next one, the line's already there. It's all multiplication. There's no at, plus, or minus. If there is plus or minus, you're going to do it different. My bases, we have 12 and 15, and then a and b. Don't repeat a and b. So 12 and 15 are each to the 1st power. Okay. Now let's talk about my a's. I got 2 of them, a -3 and a 1. Okay, so -3 and 1. The -3 comes from the top, but the 1 comes from the bottom, so that would be minus. -3 minus 1 is -4. So the a, -3, comma 1, and then I just minus those, and that's to the -4th power. Okay, now the b, I got -1 and 1, so I got to decide out what, it's not 0, just trust me. The first b is on top, the other's on bottom, so I minus. -1 minus 1 is -2. So the b is to the power of -2. Okay, so this one I do have some negative powers that need to be moved. So 12 and 15 maintain their place. But a and b are both going to the bottom so that their powers can become positive. So 4 and 2. So that's 12, and that's 15. Times a to the 4th times b to the 2nd. Now 12 and 15, you know how they're on opposite sides of the line. So we try to reduce those by a common factor. You can divide them by 3. So that's 4, that's 5. Okay, next problem. Again, no multiplication, so underline it. So I have 2 and 6 as my numerical bases, and then x and y as my variables. There's nothing on bottom right now. There will be soon. So 1 times -2 is -2. And then it's just 6 to the 1st. Now I have 2 x's. I need to multiply 3 to -2. It's -6. and then negative 3. So now I got to do some math with the negative 3 and the negative 6 and negative 3. So they both come from the top. So what we need to do is add them, and that's negative 9. Okay, and then the y, negative 2 times negative 2 is 4. Okay, so I do have some negative powers, so those bases need to be moved to the other side. The 6 to the first and the y to the fourth maintain their places. 2 goes to the bottom and x goes to the bottom, and then the powers 2 and 9 become positive. So 6 to the first is 6, 2 to the second is 4 times x to the ninth. Those big coefficients are on opposite sides, so we reduce them down by common factors. So divide by 2, that's 3. Divide by 2, that's 2. So 3 over 2 times x to the ninth. Okay, no adding and subtracting here. Extend the line, and then I make 3 boxes. And here's what I have. Get the y out of there. I don't know why that's there. So I've got 8 times a times b. So the 8's just to the first, but the a, I have a 1. I have a 4, and I have a 3. So I got to do some math with 1, 4, and 3. The first two a's come from the top, then we move to the bottom. So plus and minus, and that equals positive 2. So the a is to the power of 2. Okay. B, I have negative 3 and negative 2. So negative 3 comma negative 2. Now I need to do some math with those. The first b is top, and then we move to the bottom, so that'd be minus. But when I'm minusing a negative number, I actually end up adding it, and that's negative 1. So b is to the power of negative 1. So the 8 and the a stay where they're at, 1 and 2, but the b goes to the bottom where it becomes 1. Then that's 8 times a to the second, and if it's to the first, you can write b to the first, but it's really just b. All right, now when we have an adding or subtracting, which we do here, 4x minus 2, I don't draw the boxes, I don't do the line. We eliminate the power and then duplicate it, and now I actually multiply. So I take 4x times 4x, 4x times negative 2, negative 2 times 4x, negative 2 times negative 2. So that's 16x to the second, negative 8x, negative 8x, and 4. That adds to negative 16x, not 0. And there you have it. Okay, now we're solving equations for the x variable. There are 3 solutions because we have a third power. I have this and this, means we have to factor. It says by factoring too. So GCF and the difference of perfect squares. Set that up. Okay, so the GCF, well, they both have x third x, so it'd be x, and then let's talk about 18. So 118, 2, 9, 3, and 6. I don't think 50 is actually going to divide by any of these other than 2, so the GCF's 2x. So I factor out 2x, then I divide by 2x. That's going to be 9x squared minus 25. Circle 2x because I use that. DOPS, yep, 5 and 5, and then 3x times 3x. So 3x plus 5 and 3x minus 5. That's prime. And that has a minus, but it's prime because those aren't perfect squares. So now my factors, I had 2x times 3x plus 5 times 3x minus 5 equals 0. So my 2x can equal 0, my 3x plus 5 can equal 0, my 3x minus 5 can equal 0. So I divide by 2 and I get 0 for my first answer. 3x is negative 5, then I divide by 3, and that's going to be negative 5 over 3. Plus 5 plus 5, 3x equals 5, so I divide by 3, and that's 5 over 3. Okay, there'll be 3 answers to the next one because we have all these different powers of x, so we're going to have to factor. So GCF, and this time there's 3 terms, so it's going to be the T chart. GCF, well, they all have x, x third, x second, and x, so I need to divide by x. Circle that. Now divide by x, and now I have 1x squared plus 9x plus 18. 1 times 18 is positive 18. Sum equals 9, so that'd be 3 and 6. And a is equal to the 1, so I just need 2 parentheses. So the x was to the second, so it's just x, and then 3 and 6. So I have plus 9x, so plus 6 plus 3. Both are prime factors. So I have x times x plus 3 times x plus 6. So the x can equal 0. That's your first answer. X plus 3 equals 0. Negative 3. And then x plus 6 equals 0 and be negative 6. Okay, my next problem. 5 answers because x is to the 5th. Lordy. So GCF, and then there's 3 terms, so we go to our T chart. GCF, well, we don't have a negative, x fifth, x third, and x, so I need to factor out an x. 3, 18, and 15 can all be divisible by 3. So 3x, circle that. Now divide by 3x. And I get 1x to the 4th minus 6x to the 2nd plus 5. 1 times 5 is positive 5, sum of 6. And how about that? 1 and 5. Okay, a is equal to 1, but it's not just x to the 2nd, it's x to the 4th. So down here I need x second and x second. 1 and 5. So I have minus 6, so minus 5, and a sum would mean they're both minus. Now this is adopts x and x, 1 and 1. So x, 1, 1. Now those are both prime because the rod is second powers. And x squared minus 5, it's everything, but 5 is not a perfect square, so that's prime. So look at your factors. You got 3x from the GCF, and then x plus 1 times x minus 1 times x squared minus 5. Okay, so 3x equals 0, x plus 1 equals 0, x minus 1 equals 0, x squared minus 5 equals 0. Divide by 3, so 0 is our first answer. Minus 1, I get negative 1 as my second. Plus 1, I get 1 as my third. Plus 5, x squared equals 5, and then I need to square root. I don't need the I because it's not negative, but 5 is a prime square root, so it stays square root 5. So it's plus minus, so I have square root 5 and then square root of 5 negative. Okay, and then my last factoring problem, there's 3 answers, but this time I have 4 terms, so we're going to the grouping. Okay, so parentheses plus parentheses, space parentheses plus, get the pluses between them, space parentheses. So I place 4x cubed plus 8x squared, and then negative 9x minus 18. So I can divide these by 4 and x squared, not just x, because I got third and second. You got to get the smaller one. Here it'd be negative 9, but no x's, because 18 doesn't have an x. So 4x squared gets pulled out, and negative 9 gets factored out, and hopefully these end up the same. So it's going to be 1x plus 2 and 1x plus 2. They're the same. So 1x plus 2 goes out, parenthesize it, and then cross them out. So I'm left with 4x squared minus 9. This is a prime factor, but that's adopts 3 and 3, 2x times 2x. So 2x, then 3 and 3. And those are now both prime. So I've got 1x plus 2 times 2x plus 3 times 2x minus 3 equals 0. So 1x plus 2 equals 0, 2x plus 3 equals 0, 2x minus 3 equals 0. Minus 2, I get negative 2. Minus 3, I get negative 3. Divide by 2, so it's negative 3 over 2. Plus 3, 2x equals 3. Divide by 2, and then that's positive 3 over 2. Okay, next we're not doing the volume problem. We're not doing those. Go to this. Solve the equation. You're solving for x, but it says it won't factor. So there's 3 answers. So when 4 terms don't factor, no, you don't use a song. That's for 3 terms. 4 terms, we need the synthetic L. Okay, so what I need to do is find my first answer by trial and error. So I start plugging in. We plug in 1 to the third minus 8, and then 1 to the second plus 11, and 1 plus 20. That didn't equal 0, so now let's try negative 1 to the third minus 8 times negative 1 to the second plus 11, and then negative 1 plus 20. That worked. So negative 1 is my first answer. Now that's my divisor. So 1, negative 8, 11, and 20. So I drop the 1. 1 times negative 1 is negative 1. So that's negative 9. Times negative 1 is 9, 20. Okay, and that's 0. So now the 1 goes from x to the third to 1x second minus 9x plus 20 equals 0. Now, GCF, there's not one. T-chart. T-chart works pretty easily here. 1 times 20 is 20. Sum of 9, and that's 4 and 5. A is equal to 1, so I need just 2. Okay, so XX, 4, 5. They'd both be minus because the 9's minus and it was a sum. So x minus 4 equals 0, x minus 5 equals 0. So I plus 4, and I get 4. Plus 5, I get 5. Okay. Okay, story problem time. First one's easy. During the period 1992 to 2000, the number of people in cross-country skiing, and then here's the equation for that. T is the year since 1992, and C is the number of cross-country skiers. Calculate how many cross-country skiers were in 1992. So here's my equation. I write that down quickly. Now tell what the variables mean. So C and T. T is your skiers, it says. Read the problem. It's in millions. And T is the years, but more specifically the years since 1992. You got to include that. Only thing you have to do is, and by the way, cross that 1992 out. I want that to be 2000. Okay, so 2000 in the end of the problem. 2000 is a year, it goes in for T, but I need to minus 1992. That would give me 8. So 8 goes in for T. I don't put anything in for C because they don't give me any cross-country skiers. That's the answer to the problem. So 0.067 and then 8 to the third minus 0.107 and then 8 to the second plus 0.27 and then 8 plus 3.5. I got 33.116, so it's about 33 million. That's all there is to that one. All they give you is a year. You just plug it in. Luckily, I'm plugging it in for T and not C. Okay? Last one. A company's profit can be modeled by this equation. X is the number of items in thousands, P is a profit in thousands. What other number of items produce the same profit? So the equation is given. Whenever they write an equation, I need to write it down and then analyze it. So P is our money, that's profit, and X just says items. Okay, and they're both in thousands. I'm going to put K and K. Okay, so what values am I given? Oh shoot, I screwed this up. Here's why I screwed up. I need to write that 2,000 items currently is making a profit of $14,000. I should have wrote that. That's what I needed to give that to you. Okay, so I get 2 and 14. Don't need 1,000, okay, because they're in thousands, so I just use 2 and 14. Don't use extra zeros. So the 2 is items, so that's an X value, but then at the same time, the P is profit, so that is a P value. So those got to go in, both go in the equation. So 14 goes in for P, and then I put -2 in for all of my X's. Okay, so now I punch it in the calculator and make sure, verify that that's right. -5, 2 to the third, plus 6, and then 2 to the second, plus 15, and then 2. Please be 14. It is, okay? Now, they want the 14 to stay. They like making 14 million. It's a good profit, but they want to find other X's that can give them that. So that has 3 answers, and we already know one of them is the 2 that was given. So now I can synthetically divide by 2, but I need to move the 14 over. You got to clear one side before you synthetically divide. So I got -5, 6, 15, -14. Drop him. It's -10, then add -4. It's -8. 7, and 14. So now that -5 goes from x third to x squared minus 4x plus 7 equals 0. So GCF and then the T. GCF, you actually need to do a -1 here because of the negative in front. So I get 5x squared plus 4x minus 7. So -35, difference of 4. There's no way that works, so I go to my quadratic formula. Opposite of B, -4. Plus or minus the square root, B squared minus a 4, a 5, and a -7. And then 2 times 5 is 10, because this is our new ABC after the GCF's out. Okay, so I've got -4 plus or minus and then 10. So I square root that on my calculator. It's not going to be domain error. Sorry about your bad luck. So 4 to the second minus 4, 5, and -7. Okay, I come up with 12.49, or I'm just going to put 12.5. Okay, so -4 plus 12.5 is 8.5 divided by 10 is 0.85. That's like 850 because it's in thousands. -4 minus 12.5 divided by 10, -1.65. The negative makes no sense. These are the 2 legit answers. And they're X's, so they're thousands of items. So K items, 0.85 thousand is 850. Okay, so again, they gave me 2. So they give me 2 values for each variable. We plug them in, both of them, verify it. Then we keep that the same, and those go back to X's. And then I'll be able to synthetically divide because I'll have been given that number.